All right, folks, showtime.
The water cycle.
If it doesn't stop raining soon, the game's going to be canceled. Relax. Now we have time to catch up on cartoons.
When a puddle dries up, you might think that the water is gone, but it's not. It has evaporated into use so much fresh water that you might think we would run out. But we don't.
Change the channel. I thought you said we were going to watch cartoons. I'm trying, but I can't find anything but this water channel.
Since the Earth. This is called condensation. If you take heat away or cool, the cycle begins again. You see, water is everywhere. About 70% of our Earth is covered by water, and water isn't good.
What's going on? This water stuff is everywhere. They're all the water channels.
See? I told you, water is everywhere.
Are you talking to us?
Well, who did you think I was talking to?
Who are you?
Why, I'm lukewarm.
So why can't we watch anything but the water channel?
Well, as I said before, water is everywhere, and it's always moving from the Earth's surface into the air and back to the surface again. It never stays put. This constant movement of water is called the water cycle.
So what's so big about the water cycle?
Well, why don't you take a look and find out? Select water on the menu. Water. About 70% of our Earth is covered by water. Most of that water is the salty water found in oceans. There are a lot of animals and plants that live in the salty oceans, but salt water isn't good for the animals and plants that live in fresh water or on land. Let's say that this aquarium full of water represents all the water on Earth. Only a small amount of the Earth's water is fresh water, and an even smaller amount of this fresh water can be used by living things. This is because most of the fresh water is frozen in glaciers, or it's polluted. Out of all the water on Earth, this is all that's left for living things to use. All living things need water to live. There would be no life on Earth without water. Did you know that about 66% of your body is made up of water? A tomato is about 95% water. Water is the source of weather. Without it, there would be no rain or snow. Water also helps to make storms and winds. Water can even change the surface of the Earth. The force of running water can carve canyons in the Earth. Glaciers can plow through mountains, leaving behind valleys. All the water that we have on Earth today has been around since the Earth began. This means that the water you used to brush your teeth with this morning is billions of years old. Columbus could have brushed his teeth with this water. People use fresh water every day. We use it to drink, bathe, water plants, and for many other things. Now, we use so much fresh water that you might think we would run out, but we don't, because it's constantly being renewed by the water cycle. Water can be used over and over again. It can never be used up. Heavy precipitation continues in the northwestern region of the United States, which is really no big surprise.
I wonder if the game is going to be canceled today. Have you heard from your coach yet?
Not yet, Mom. But we're checking the weather channel right now.
Okay, well let me know if the game is called off.
Higher than this time last week. If we look at Doppler radar, we're going to see that that was close. So, girls, the water cycle renews water so we can use it over and over again.
But how does water move through the cycle?
Well, in order to understand how water moves through the cycle, we must first look at water itself. The water molecule. Take a look at water. No, take a closer look at water. Water is made up of tiny particles called molecules. These molecules can be very close together or very far apart. The position of those molecules determines what form water is in. Now, as you may already know, water has three forms. It can be liquid, solid, or gas, depending on how much heat or thermal energy is in it. As the temperature changes, the form of water changes too. Very cold water is a solid. The water molecules are very close together. When solid water is heated, it turns into a liquid, allowing the molecules to slide freely around one another. When liquid water is heated some more, it turns into a gas called water vapor. The molecules are now very far apart and they fly around one another. If the water vapor is cooled, the molecules will get closer together and it will turn back into a liquid. Turn down the temperature even more and it will turn into a solid.
But what does that have to do with how water moves through the cycle?
That's an excellent question, Rebecca. It all starts with the sun.
The sun?
That's right. The sun. The sun is one of the most important parts of the water cycle. It is the source of the water cycle's heat energy. As water moves through the water cycle, it changes form, from a liquid to a gas and back to a liquid or a solid. Water goes through these changes because it absorbs and releases heat energy from the sun. When liquid water molecules absorb heat energy from the sun, they start to move rapidly. The moving water molecules rise into the air and become an invisible gas, water vapor. When the water vapor rises into the air, it begins to cool. As it cools, the water molecules slow down, get closer together, and turn back into liquid water droplets, forming clouds. If it is cold enough, the water will turn into ice crystals. As the water droplets or ice crystals get bigger and heavier, they will fall to the earth as either rain, snow, sleet, or hail. After the water returns to the earth's surface, the liquid water will either move through rivers, lakes, and streams to the ocean, become groundwater, or go back up into the atmosphere. As more water rises into the atmosphere, the water cycle continues.
Wait a second, you lost me.
Ha! Tune in to this. Evaporation. When a liquid changes to a gas, it is called evaporation. As liquid water is heated, the water molecules start to move very quickly. They will fly off into the air or evaporate into the invisible gas, water vapor. How quickly water evaporates depends on how much heat is added. You can see this if you place one dish of water in the sun and another in the shade. The water in the sun will evaporate more quickly than the water in the shade. When a puddle dries up, you might think that the water is gone, but it isn't. It has evaporated into the air. If there are any materials in the water, like salt, they will be left behind when the water evaporates. That's why the salty ocean can supply fresh water to living things on land. The water is separated from the salt by evaporation. Water vapor is all around you in the air. You can't see water vapor, it is invisible. The white stuff you see when you boil water in a teapot is not water vapor. It's actually a bunch of tiny droplets of liquid water. That's the same stuff clouds are made of. The water vapor is in the space between the teapot spout and the cloud of liquid water droplets. Even though water vapor is invisible, sometimes you can feel it in the air. Have you ever walked outside just after a rain? Air feels damp when there is a lot of water vapor in it. The measure of how much water is in the air is called humidity. If there is a lot of water vapor in the air, it is very humid. Water is always evaporating from the Earth's surface. The sun heats hundreds of thousands of gallons of water from the Earth's surface and causes it to evaporate every day. Now that is enough water to fill a lake.
Wow, that's a lot of water evaporating. Where is it all coming from?
Well, most of it comes from the oceans.
So why haven't the oceans dried up yet?
That's an excellent question, Rebecca. And the answer is condensation. When a gas cools enough, it changes to a liquid. This is called condensation. If you take heat away or cool a gas, the molecules will slow down. They actually move closer together and condense into a liquid. The water molecules that make up water vapor move very slowly when they are high in the Earth's atmosphere. This is because it is very cold there. When the water molecules lose heat energy, they slow down and condense into liquid water. The liquid water forms droplets so small they can float in the air. Clouds are actually millions of these droplets close together. So is fog. If the temperature stays warm enough, the droplets stay liquid. But if it is cold enough, the droplets will freeze into ice crystals. Both the droplets and ice crystals get bigger and bigger as more water vapor condenses onto them. They also bump into each other and join together, making even larger droplets and crystals. So after water evaporates, it condenses into either liquid water or solid ice crystals.
So what happens to these droplets and crystals?
You see, Sydney, that's when precipitation happens.
Precipitation?
Yes, indeed. Precipitation. If the droplets and crystals get too heavy, gravity pulls them to Earth. Remember, gravity is the force that pulls things toward the center of the Earth. The droplets and crystals fall in the form of snow, sleet, hail, or rain. All of these things are forms of precipitation. Temperature determines the form precipitation will take. When the air near the Earth is warm, the water particles in the atmosphere absorb heat energy. Then the ice crystals in clouds melt as they fall to Earth. They change from a solid to a liquid called rain. However, in tropical areas like Hawaii, the temperature even high in the air doesn't get cold enough for water to freeze. When this happens, the water droplets in clouds come together, and they get bigger and bigger until they become so heavy that they fall to the ground as rain. But sometimes the ice crystals never melt. If the air near the Earth is cold, precipitation will fall as a solid. Snow, hail, sleet, and ice are forms of solid precipitation. Snow is actually made up of small crystals of frozen water. The crystals gather together as they fall and form snowflakes. Hail falls more than once. Hail is made up of pieces of ice that fall and then are blown back up into the air by wind. Each time a piece of hail goes up and down through the air, it collects more water and gets bigger. Hail can be as small as a pea or as big as an orange. Sleet is made up of raindrops that freeze as they fall to Earth. Sleet is smaller than hail.
Wow, so ice crystals and clouds get bigger and heavier until they become so heavy that they fall as snow, hail, or sleet. Yes, but only if it's cold. If it's warm, the ice crystals will melt into rain.
But remember, not all rain starts off as ice. Sometimes the temperature is warm enough that the water never freezes into ice crystals. Now when that happens, the droplets get bigger and heavier, and they fall as rain.
But where does water go after it falls as precipitation?
Good question. Where does it all go? Water can go many places after it falls to Earth. Most precipitation falls onto the oceans, but some falls on land. Precipitation that falls over land may fall directly onto rivers and lakes. Some of the precipitation that falls on the land runs across ground and drains into streams and rivers. This is called runoff. The rivers and streams will eventually take the water to the oceans. Other precipitation that falls over land soaks into the ground and becomes groundwater. Groundwater is water that moves under the Earth's surface through small spaces in rocks and soil. Some groundwater eventually seeps into streams and rivers. Other groundwater is absorbed by plant roots. The water is used by the plant and then released back into the air. This is called transpiration. The rest of the precipitation that falls onto the land evaporates back into the air.
Hey look, it stopped raining. Let's get to the field. Come on. Hang on a sec. How long does it take for water to go through the cycle?
Water can move through the cycle very quickly or very slowly. It all depends on where the water goes. After water molecules evaporate from the ocean, it might take a week or two for them to return. But if the water molecules get frozen in a glacier, they can stay there for hundreds of years. And if water molecules run into groundwater, they can stay under the surface of the earth for thousands of years.
So, do you think that the water on the field has evaporated yet?
Well, that depends on the temperature. Water on a warm, sunlit field might evaporate in a very short time.
Guess the game's on. Let's go.
Don't forget this.
Thanks.
For more great curriculum-coordinated programs, call 1-800-483-3383 or visit us online at schoolvideos.com.